is on page 33. If you have some highlighters, have those ready too. And so far, we explored how scale factors affect the dimensions of an object. Okay? But how does enlarging or reducing an object affect the area, right, or surface area? That would be two-dimensional. Or how does it affect your volume? Right? So we'll explore this a little bit. So maybe at some parts, I'm just explaining why this works. And then we'll actually use the formulas that I developed, that I derive, okay? So let's explore. Consider the following rectangular prisms. Assume that the original has been enlarged by a scale factor of 2. So the original, we had this, and then we made a bigger version, obviously right next to it. When everything is affected by the same factor, we also say, this is another way of saying these are similar shapes or objects. Okay, if you see the word similar in this unit, it's not just saying, hey, they're kind of alike. It actually tells us that something has happened and it has been changed by the same factor all around, every single dimension. Okay. So basically, to go from the original to the new one, we basically just multiplied it by 2. That's basically what's going to happen. Every dimension will be enlarged by a factor of 2. So if this is 5, notice what I'm going to do here. I'm going to do things a little different. If this is 5, then this will be a K5. K multiplied 5. And this, we know it's 2. K is supposed to be 2, but I'm just going to go K5 right now because I want to prove a point here. So let's call this length, width, and height, obviously. And so when you have the original width, you would multiply this by 2 to get the new width here. We're just going to call this K2. And then the height is K3. So naturally, in this particular example, if K is 2, this would be 2 times 5, which should have been 10. This would be 2 times 2, which is 4, and this is 6. But I'm just going to keep it like that for now. Okay. It does say determine the dimensions, the length, width, and height of the new prism. We're just going to put that down here. So this would be 10 centimeters. This would be 4 centimeters. And this would be 6 centimeters. Stop a bit. Determine the surface area of each prism. So here I'm going to change it up a little bit from what I used to do. Okay, so here we go. The surface area of the original, make sure you stay way up top here because I'm going to use most of the space here. So kind of use the same amount of space that I'm using. So you'd go 2 times length times width. Length times width is 5 and 2. So we go 5 times 2. Just write it down like that. Plus 2 times length times height. So that'd be 5 times 3. Plus 2 times width times height. That'd be 2 times 3. There we go. So that's how you would start. I'm going to leave it like that. I'm not going to work this out. Okay. Let's figure out the surface area of the new shape, the new resulting prism. Can you see all right from back row? You can see? Okay. I'm just going to, for me it's a little harder. Let's continue. So for the new one, for this one here, I'm just going to use the K's here. You go 2 times length times width, so K5 times K2 plus 2 times the length times height, K5 times K3 plus 2 times K2 times K3. Let me zoom into that. I can't because I want to make sure you get this right. I'm going somewhere with this, so just trust me, okay? So you can see that the scale factor is appearing everywhere, but if you were to multiply this out, K times K is K squared, right? So here it goes. Surface area of the new is 2, watch this, K squared times 5 times 2. Like the 2 and the 5 are still multiplying each other, these two here. So I'm not just figuring out the number because I want to compare it to the very first line we did here. The next one will be 2 times K squared times 5 times 3 plus 2 times these two K's would be K squared times 2 times 3. And I don't know if you start seeing a pattern there. Let's do one more step here to show what's happening. Just make sure you have this written down because I want you to see what I'm doing here next. All right. I'm going to take, you remember factoring things out? Do you remember that from IAPR? Sort of. There is a K squared in every single one of these brackets. And you can factor that out. You can take that out. So this is what's going to happen. We're going to start our new line with K squared. And watch what I'm going to do. I'm going to use a square bracket like this. So for the very first expression, you end up with 2 times 5 times 2, the K squared is gone, plus 2 times 5 times 3, the K squared is gone, plus 2 times 2 times 3, square bracket closed. So here's our K squared now. It's outside. And look at this part compared to the original. You see that this is copy paste in there? So I'm actually going to do this here. So now I'm gonna replace all of this with surface area of the original. I'm gonna put that in here because they're really the same. Okay. So surface area of the new prism is K squared times surface area of the original. I know this is Monday morning. You're like, slow down there, slow down. I hope you see what I did here, right? I actually showed how the K multiplies everything, how it finds its way into my new formula. Then I kind of manipulated it a little bit, factored out the K squared to show, hey, it's really like to get the new one, you would just have to take the scale factor, square it, and multiply it by the surface area of the original. That's how that would be another way of getting there. So from this, I'm going to derive my formula, okay? I'm just going to say I could technically divide surface area of the original on both sides. Make sure you write this down. And the surface area of the original would just cancel out here. So you're left with this, and this is what I want to end up with. This is going to be the formula that I just developed. So I'm going to cut this here. I'm going to cut it right there. And I'm going to have two big formulas right now. I'm going to zoom out a little bit. There you go. So I'm going to rewrite this, but I like to have the k squared first. So to conclude, k squared is surface area of the new over surface area of the original. This I'm going to box in. This is the most important piece here. Remember before, when we just talked about scale factor, it would just be new over original, correct? And by that I meant length, width, height, radius, so forth. Now it's going to be surface area. So how do you know that you're dealing with surface areas? Your units will be squared, right? You'll have squared units here, squared units there, and they'll cancel out. I also want to give you the other version of this. K squared is surface area of model. No, it was diagram, right? Sorry, I'm just gonna. I think I talked about diagram. Yeah, I'm just gonna go back to where it started talking about. Like I'm talking. So we talked about new original, and I'm gonna rewrite it using diagram actual. So k squared is surface area of the diagram. Sometimes this wording is more useful or helpful. Talking about, because some questions actually talk about a diagram and the actual, so then I'd rather stick with this formula. Okay. Now, let's do volume. Volume is a little faster, a little quicker. We're going to do volume of the original. It's just length times width times height. So it would just be 5 times 2 times 3. Volume of the new one, it would just be K5 times K2 times K3. Volume of new, right? If you go K, these three K's would end up being K cubed. I'm going to take it out already and just be left with 2 times 3, sorry, 5 times 2 times 3. Here's my K cubed. Here's my, right, this is the original right there. So my next line will be volume of new is K cubed times volume of the original. And I'm going to divide both sides by volume of original. Cancel that out here. And this is what I want you to be left with. And I'm going to conclude here that a cubic K cubed, scale factor cubed, is what you would use if you're using volume of new over volume of original. That's one of them. Or K cubed is volume of diagram over volume of original. Okay, so this is just deriving the formulas that we're going to use from now on. Oh, I know what this is actual, right? Sorry. I wish I would have the time to edit this out of the video, but there we go. Yeah, let's be consistent with the terminology because this is confusing as is. Never mind if I start mixing things up, right? Now, I want you to remember something. When the question, like if you're dealing with areas or surface areas, you want to be thinking of one of these two formulas. If it's talking about volumes, you want to be looking at one of these two formulas. And the question, you will have to know at least 2 out of the 3. Okay, guys? 2 out of the 3. You need to either know the scale factor and the surface area of the original, scale factor and the surface area of the new, or both surface areas, right? Like it depends on the scenario, but then you need to know 2 out of the 3 things. So the question will provide that. You just have to plug it in and put them in the right spot and go from there. Okay. Let's go to page 34 and explore this a little further. Page 34, here we go. Consider the 2 similar cylinders below. And by the way, I used software. These are actually drawn to scale, okay? These 2 shapes. And so I'm going to walk you through it. By what factor has the height and the radius been affected? Let's make sure we understand the height and the radius. These are one-dimensional. Okay, you can actually measure the length and the height or the width or anything like that. So basically what I want you to think of here is just K is going to be the height. Let's get this right. If this is the original, then what is this? This is the new, right? I'm going to call that the new. If this is the original and this is new. So the height of the new divided by the height of the original. That's what they're asking for. Like, what's that scale factor? So you would go height of the new is 15 inches and the height of the original is 5 inches. That's pretty easy. Units cancel out. 15 divided by 5 is 3. There it is. And for the radii, right, we would go same thing. K is the equivalent of radius of the new divided by the radius of the original. Radius of the new one is 9 inches. Radius of the original, 3 inches. Cancel out. 9 divided by 3 is just 3. This could be decimal. This could be a decimal. Don't get me wrong here, but I just kept it simple here. So the height and the radii have the heights and the radii have been affected both by 3, and that's what we expect, right? It's the same everywhere. Okay, so this is where it changes a little bit. By what factor has the surface area been affected? Surface area, 2-dimensional, right? 2D. Okay. So you cannot just use K. That's the #1 mistake students make in this case. Okay. You have to know this is 2-dimensional. Therefore, I'm going to go K squared is equal to surface area of the new divided by surface area of the original. So K squared is going to be, let's be careful here, we compare both surface areas. So we're going to go 1357.5 0.1680 squared inches divided by 150.79, and use the decimals because I used 4 decimals here to make sure we get the same. So when you cancel those units out, let's figure out what this is when we divide that. I invite you to do the same thing here. If you divide that, you get 9. Sorry, I'm going to make sure you see that. You get 9, right? So the surface areas have been affected by a factor of 9, but really, this is what? This is 3 squared, isn't it? We take the original scale factor that we had, scale factor, what did I say? Scale factor, we're not scared of this, right? We take this and we square it. That is what the areas have been affected by. They have been affected by a factor of k squared, which is 9. Okay, so surface areas have been affected by a factor of k squared, which is 3 squared, which is 9. This is what they have been affected by 9. We figured that out just by dividing, but we could have also just answered by saying, hey, I know my scale factor in the one-dimensional realm, so I'm just going to square that and know that it's by a factor of 9. The areas have been affected by a factor of 9. Okay. Next, let's look at the volumes. What do you think the volumes will have been affected by? K cubed, right? All right, let's do this. K cubed, volume of new over volume of original. So we have 3817.0651 cubic inches divided by 1413717 cubic inches. Let's put K cubed here. Yeah, let's just make sure we have that. So what number are you expecting? I hope you're thinking I picked easy numbers. You should be expecting 27 because 3 to the power of 3 is 27. But let's see if that actually works out. I know, this is mind-blowing, isn't it? 27, no units there. But that is really 3 cubed, right? That 3 cubed. So this is going to be our standard answer. The volumes have been affected by a factor of k cubed, right? So 3 cubed is 27. Okay, so we still say by 27, by a factor of 27, but I want you to know that it all started with the scale factor, the original scale factor here. What is the actual scale factor? Actual scale factor is k is equal to 3. In other words, if you want the actual scale factor, it should just be k. There should not be k squared or anything else there. It should just be k. So that's it. 3 formats. 3 and decimal would just be 3. We would say 300%, right? Both of them. You could write it as a decimal, but in this case it wouldn't change anything. It would still just be 3. And so the new shape is 200% larger. We go 300% minus 100%. So it's 200% larger, right? If you are at 300%, that means that you enlarged it by a factor by 200%. All right. Let's see here. I want you to try to walk through these steps again one more time. Go to 35 and try to apply what I just did to page 35. This is a reduction, by the way. So let's see how things change when it's a reduction. And then we'll do some more examples where you have to do solving for the unknown. Thank you, guys. Just wait. I'm just quietly working through it if you want to compare. Maybe I'll just mention here that as soon as you see centimeters squared, that should be a reminder to make sure you put a squared on your K, right? That's a very good reminder that everything, you will see later how that's very, very important to get that right. So we cancel out. I want to stop there. If you can come back up front here for B. This one is harder to see, isn't it? How is that relevant to that, right? How is it? If let's think of if it's K squared, what do I need to do to both sides to just get K? Remember Pythagorean theorem? Square root. Square root both sides. Let's do that right now. I didn't do it earlier because it was very easy to see, but we're going to square root, square root, square root. Okay. So that cancels out here. And did I show you how to square root with this calculator? I'm not sure. But if you look up here, you just have to press second and then x2, right? Above x2, there's a square root symbol. And then I'm just going to go up, arrow up, copy that, paste it, and hit enter one more time. I stayed it to 4 decimals. It's not a big deal. Do you see if you go back up to this one here, whether or not you reduced it, it doesn't really matter. If you turn that into a decimal, you get 14.29. Sometimes that's the way to go. If you have, if you're not sure, turn your fraction into a decimal, and there you see, it's like, hey, wait a minute, the scale factor is still the same, right? The scale factor has not changed at all. It's just that my areas are affected by a scale factor of k squared. So this is the scale factor. Okay, that is what we would still refer to as my scale factor. That's the one that every dimension has been changed by. Can I also say k is less than 1? So without looking at the diagram, I would know there has been a reduction. Okay, there has been a reduction because of that. So didn't ask for it, but I want to make observations because I want you to see how everything is connected, right? You can look everywhere you want and see that, oh yeah, this makes sense, right? We go on. So this was just a complete aside. But I will still say that surface area has been affected by, you might want to say 1429, correct? That would be right now incorrect because surface area has been affected by k squared, okay, which is 0.0204. That's what I got inside the root here. By the way, I'm going to go back to my calculator. I don't know if you remember me showing you this, but if you go up to 0.0, this one here, and you copy it down, hit enter, and you go math fraction, let's see if it turns it into a fraction. It should be 1 over 49, because 1 over 7 squared would be 1 over 49. Let's see if that works. It can't do it because of rounding, so let's just leave it like that. But if you go 1 divided by 49, if you want to check that way, it's very similar. It's very, very similar, close enough, right? I will maybe say here 1 over 7 squared, it is 1 over 49, which is 0.020 and so forth. Put that on the side there. Okay. It's okay to scratch your head a little bit after this, guys. It's okay. I'm gonna do more examples. We'll walk through this together. By what factor has the volume been affected? We're gonna show, remember it's volume. Volume, that's three-dimensional. So you should know, okay, it's gonna be k cubed. We're gonna take both of the volumes. The new one goes on top. And remember, centimeters cubed, okay, put a cube on k, right? Then it's 7,183,7,752 centimeters cubed. Cancel that out. And when we divide that, I invite you to do the same if you haven't done so already. You get that. 0.0029, and that keeps going. How do you take the cube root with this calculator? I'll show you. So just follow me, okay? Hopefully you have your calculator out. It's a pain, but it's not too bad. You have to press math, the math button. And if you scroll down, oops, Let's try this again. Math, and then you either press number 4 or you scroll down to 4, select it, and then just copy that number, paste it inside the cube root, and there you have it. What do you know? It's still 0.1429, correct? Nothing changed. Still, I'm going to go orange. The actual scale factor hasn't changed, but the volumes have been affected by k cubed. Okay? Volume has been affected by k cubed, right? Which is 0.1429 cubed, which is this, 0.0029. That keeps going. And a note, 1 over 7 cubed is 1 over, I forgot what 7 cubed is, 343. I should have remembered that. And 1 over 343, if you go 1 over 343, it should jive, gives you that 0.0029 that we were having inside the root. Do you know how to cube? Oh, I should show you that. Grab your calculators. That's just, for example, just grab the 0.1429. If you want to cube or raise anything to the power, guys, you press this little hat here. If you press the hat, it automatically enables the exponent, and you just type in whatever you want. In this case, you want to the power of 3, right? Hit enter, and there you go. You get your exponent. You just have to watch out. Sometimes after pressing 3, it stays up there. Just go arrow sideways to bring it back to the main line if you want to do some more calculations there. What's the actual scale factor? K is actually 1 over 7, which is 0.1429, which is 14.29%. I will say this in applied, rounding your answers to 2 decimals is the minimum. If you do more than 2 is okay. Except, this is the annoying part, money. That's always 2. Your final answer is always 2 with money. You will actually lose marks if you state your final answer when it comes to money and more than 2 decimals, okay? So you got to watch out for that. This shape is how much smaller? Yeah. So again, I will just, where am I going to get this answer from? I'm just going to go 100 minus 14.29. Yeah. So yeah, there we go. 85.71% smaller. It all has to do with 100%. How much above are you for enlargement? How much below are you for a reduction? Okay. I will skip page 36 for now. Again, for moving forward, okay, guys? And I will probably tomorrow wrap it all in one package again. You want to be very aware of these formulas. You want to have these on your study sheet because pretty much everything revolves around that. However, not everything is squared or cubed. Okay, so come with me. I want to at least give you one more example where we use these formulas. And it basically allows you to find any of the 3 things that show up, either K or the surface area or the volume of either the new or the original. Here we go. An ice cream shop is making a smaller cone for smaller children. Use the diagram to answer the following. Determine the scale factor used to create the smaller cone. Okay, I need you to look at this diagram here. In this case, I'm giving you a diagram. Sometimes it's just going to be wording, but you want to look at, do you know any of the two corresponding measures? For example, do you know both volumes? You don't. Do you know both surface areas? No. Do you know both of the diameters? Yes. So that's what you're going to use to come up with your scale factor. Okay. And I already know original, replica. Have I ever used replica before? No, right? But if you see the word original, what is this? New. So just help yourself out. Just say, hey, the replica, I'm going to call that new. Okay? So just adapt to the question. So the scale factor is going to be what? New 1.77 inches over the original. And now I want you to ask yourself, what's the exponent for the inches here in this case? It's just 1. So it's okay for k to just stay with an exponent of 1. Is that I'm doing this for a reason. So this is as easy as just canceling the units, and let's just get this as a decimal. It's okay because I'm not specifying which format. So you just go ahead, 1.77 divided by 2.5. It's finite, so that's even better. There it is. Okay. We could probably do percentage. I'm just going to go ahead and multiply it by 100 to say that my scale factor is also 70.8%, but I will use this one to work as we go along. So this is your key. This is so important. Once you have that, I ask a whole bunch of questions. Notice that there are question marks here. Right? There are question marks, and your scale factor is the key to unlocking that. All right, let's use that to our advantage. Determine the amount of waffle dough required to make the original cone. And because waffle dough is like, right, it's wrapping around, essentially, we're referring to surface area in this case. Whenever you want something that needs to be covered or coated with, we're talking surface area. So surface area is two-dimensional. Okay, so we're going to go with this. K squared is equal to surface area of the new over surface area of the original. And now you have to ask yourself, what do I already know? Do I know my scale factor? Like just K itself, you do know what it is. It's right here. So you substitute that in. So we're going to go 0.708 to the power of 2. Right, I'm going to go arrow up here, substituting it into K. So we square it. Let's say you forget to square it. This is where you're going to remember, hopefully. You're going to plug in one of these two, because remember, I need to give you 2 out of the 3 things. Which one do we know from the surface areas? We know the new surface area. We know this one. So we plug that in very carefully upstairs, right, in the numerator. So we're going to go 10.15 squared inches, and that's where you should be like, oh, squared inches. Make sure this is squared to get this right. Because remember, surface areas are affected by K squared, not just K. All right? And then this one is going to be our surface area of the original. This is our unknown. We want to know what that is. And our answer is going to be in squared inches. I don't know how comfortable you are with this. Maybe I'll just square it first. Let's square everything. So 708 to the power of 2, you can just press x2 when you want to square. That's much faster than using the hat. Sorry, this is going to give me the wrong answer. 708 x2. I want you don't have to write down all of it, but I want you to use all of it. So I'm going to go 0.501 ... is equal to 10.15 squared inches over surface area of the original. Is this a proportion? Yes, it is. This is not as a fraction, but I usually just write this over 1. It's a very ugly fraction, but it still works. Putting a 1 under anything doesn't change the value. So you basically cross multiply just like before and divide. Okay, so here's my work. Surface area of the original is going to be 10.15 squared inches times 1 divided by 0.501 dot dot dot. And I'm going to put the answer right next to it. So you set up, once you set up, so watch this, you go 1015 times 1, which is just 1015, correct? I'm not going to actually go times 1, divided by, you copy paste. You just go up to that one, hit enter, enter again, and so we know now it's 20.2 what? 25, correct? 25 what? Squared inches. Which makes sense. The original is bigger. It should be a bigger number, right, than the smaller cone. So there's a lot of things that help you realize this is in fact right. So it all started with what? It was two-dimensional. Okay, so I'm going to use the k-squared version of Mr. Dirksen's formula. I'm going to plug in two things. I need two things. And I happen to know the scale factor and the surface area of the new. Plug in and go, cross multiply, divide. They're all going to end up being cross multiplying, dividing, except for one instance, which you'll see probably tomorrow. Next, watch this one. Similar setup. Determine the amount of ice cream the smaller cone can hold. Whenever you're trying to fill something, go ahead, it's volume, right? So this is 3D. Make sure you make a note of that. So in this case, you're going to start with k cubed is volume of new over volume of original. By the way, once you know the scale factor, and it's still the same question, the scale factor does not change anymore. Okay, it's fixed. So we know that scale factor is 0.708 cubed. What do we know in this case? Actually, you can see the volumes here. You know the volume of the dew. Did I make a mistake earlier, guys? No, we know the volume of the original. I almost mixed this up. But this is the volume of the original, correct? Where my pencil is? So this will go in here. So volume of the new over 24.54. And here's another hint. Whenever your units are cubed, you're going to remember, it's like, oh, okay, make sure my scale factor is cubed also, or else you're going to get the wrong answer. That's going to be a -1, right? If you get that wrong, it's a very important concept. So grab your calculator because it's important to know how to type this in, right? 0.708. Press the little hat button. Press 3 to cube it. Hit enter. There it is. I'm just going to write down just a few numbers and then go dot, 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 indicating I'm using all decimals. Volume of the new over 2454 cubic inches. The power of 1, right? How are you going to solve this one now? You cross multiply up and divide down. That's how it's different, right? Volume of new, sorry, I should say that, new is 2454 cubic inches times 0.354 dot dot dot. I'm going to show that I'm dividing by 1, but I'm not really going to compute that. And then you go 24.54 multiply my previous answer. I'm going to copy it in there, and it's 8.71 cubic inches. And it makes sense because it's the smaller cone, so I was expecting a smaller volume. Okay. I talked a lot today, I know. I will ask you to try pages 38 to 40, okay? And I know it seems like a lot, but trust me, this is not like a textbook 38 to 40 where you have like a gazillion questions, right? A, B, C, D, E, F, G. This is literally, every page has basically one major question, and I leave a lot of room for you to do the work. Okay? I know some of you, some students call me like you kill too many trees, and I apologize. But I like to have the work all in one place, not like a bunch of loose leaf questions there, here. Where was this question again? It was in the textbook. You gotta go look it up, right? When you're studying, it's all in one place. You can see the question, you can see the work. I think that's very important. So make sure you try this. Apply everything you've learned today, because sometimes I'm going to ask you for the scale factor and you're like, wait a minute, but there's a cube root it if you know both of these to find the scale factor. Okay? So try it. I'll bring it back tomorrow.